The weekend is now over. I've been driving around to 10 different sports and doing the shopping. I'm obviously running low on fuel and the weekend is over, so I need to fill up the car. But one of the things we do have here in Western Australia is we have a thing called the petrol price cycle. On certain days, the price is heavily discounted. So I only fill the car up if possible on those discount days because it saves me a lot of money. So what I do is, I'm a database guy, I keep a record in a table of when I fill up. So in this case, for example, on the 1st of August, the car was empty when I first got it, and I put in its full capacity of 35 litres. I didn't run the car down to empty again because on the 9th of August, it was a cheap petrol day. So what I did then was, even though the car was still 20% full, I then put 37 litres into it because the petrol was pure. On the 13th, the car was, I'd only used a bit of petrol. The car was 60% full, but I still threw some litres into it because that was a cheap day, and so forth. I don't run the car down to empty unless I absolutely have to. I only fill up when the days are cheap because it saves me money. I'm at that age, I'm sort of, what do we call midlife crisis age, where my car is actually quite a sporty car because, I'm trying to reclaim my lost youth. And so one of the things it says is, because you have a highly, tuned engine, try put only good fuel in the car and make sure the fuel is clean. And it even has in the owner's manual a guide to measuring the amount of impurities in the fuel. It actually gave me a spreadsheet. It says the spreadsheet is, if you fill up the car from empty, then the number of impurities, or the dirt percentage in the fuel, is the number of litres times 5%. So in this case, for every 45 litres, I'm getting 2.25, I think it was micrograms, I can't remember, of dirt and impurities in the fuel, and it lets you measure this. It says if the car is being filled up not from empty, in this case it's 20% full, well, we take the previous dirt calculation times the percent full. So it's effectively saying, okay, 20% of the tank's still there, so we need 20% of this 2.25 impurities, the previous dirt times this percentage, plus the number of litres you put in. I need to know what the previous dirt was if the car was not empty in order to have this rolling calculation. There's the initial one, but then the next calculation relies on what it was previously. So now the first calculation of the dirt is easy. It's that times 5%, but the next calculation relies on the previous one all the way down. It's a recursive relationship. And the question is, can we do recursion in SQL? Yes, we can. First thing I need is some sort of nice, simple primary key. The date would probably do, but the problem with the date is here, I don't know the distance between each date, and that just makes life a little bit difficult for me. So I'm going to add a column called a sequence using row number, which gives me a nice, simple ordering sequence to each of these rows. So I now know that row number 2 is preceded always by row number 1, as opposed to having to work out what the next date was. So that's just a nice, simple primary key for my row set. Now then, to calculate our dirt using a recursive formula. Well, I'm using the with clause here to generate my primary key. So I'm going to define a thing called the results table. And the results table will consist of the date, percent full, litres, dirt, and the sequence number. So what was the first dirt calculation? The first dirt calculation was get the first row, and the dirt was 5% times the number of litres because the car starts at empty. The second dirt calculation was that expression that refers back to the previous one. So how do I refer back to the previous result? Well, I'm querying my table called T, but I need to refer to the previous row. The previous row is this results table where sequence equals 1 less than the current sequence. So I take my table called T, get the number of litres I put in, then I look back at the results table for the previous sequence to get the previous dirt figure. That's the recursive relationship, because this results definition refers to the results definition. It's a recursive relationship. But you can sort of follow along. We have those two expressions, the starting point and how to navigate through the hierarchy of dirt, no pun intended. And I get my dirt calculation straight using a recursive SQL. That's very cool. When I show people this, they go, recursion was never my strong point at my programming course, but Excel, I'm good at Excel. I'd rather just use Excel formulas, thank you very much. Which is all well and good, but of course Excel doesn't scale to billions of rows, whereas the database will. Wouldn't it be cool if you could actually write Excel, but in SQL? And you can. Let's look at what an Excel spreadsheet looks like. An Excel spreadsheet looks like a definition of what the rows are. And we have that here. We have this dimension column for a model clause. We want something that gives me an identifier for the rows, which is dimension by this. Obviously, I need some columns, date, percent full, liters, etc. They're called our measures. We insert those as well. Dirt is a new one. It's a calculation, this one over here. So I'm going to initialize it to 0. Now I need some rules, just like the rules over here. What's the first thing for dirt? It's liters times 0.5. That's the first row for dirt is liters times 0.5. What do all the subsequent rows have in them? Well, anything with a sequence is greater than 1 is the previous value times the percent full times liters. So this looks very, very similar to your standard Excel formulas, and we get the same result. So even if you're obsessed with Excel, you can port your Excel with a little bit of understanding of these rule syntax into SQL statements and get the benefit of both.